Welcome everyone. This video is the third part of chapter 3 Atoms and Molecules, class 9 chemistry. Class 9 chemistry, chapter 3 Atoms and Molecules. Part 3. So we have come to know the laws of chemical combination, and there were the 5 laws of chemical combination. And among these 5 laws of chemical combination, this law of conservation of mass and the law of constant proportion, which is also called as law of definite proportion, are important for you, you can say. In ninth class, the law of conservation of mass and the law of constant proportion is present in detail, and the other laws you will understand in detail when you will go to the 11th class. So remember these two laws. The first one, law of conservation of mass, was mass can neither be created nor be destroyed in a chemical reaction. There was an activity in which you had seen that mass before the reaction was equal to the mass after the reaction. Meaning is that in a chemical reaction, mass is conserved, which means mass on the reactant side must be equal to the mass on the product side. And it was the law of conservation of mass, and the law of constant proportion, which is also called as law of definite proportion, was when elements combine to form compound. Elements, where are the elements? Elements are present in the periodic table. So when elements combine to form compound, they will combine in a fixed ratio by mass. Meaning is that if we are considering water compound, no matter from which place we are taking this water, whether we are taking water from Australia or from India or from America, the water of every place will have the same element, which is hydrogen and oxygen, and it will combine in a fixed ratio by mass. And it was the law of constant proportion. So we will focus over these two laws in ninth class. Early people faced problem to explain these laws. So you can write down, early people faced problem to explain these laws of chemical combination. In 1808, John Dalton gave a theory called as Dalton's atomic theory. Dalton's atomic theory was based on the laws of chemical combination. Dalton's atomic theory, which was given by John Dalton in 1808, was based on laws of chemical combination. So you will remember Dalton's atomic theory was based on laws of chemical combination. So early people faced problem to explain these laws, and the theory which was explaining the laws of chemical combination was Dalton's atomic theory. So you will remember that Dalton's atomic theory was based on the laws of chemical combination, and the postulates of these Dalton's atomic theory are postulates of Dalton's atomic theory are, the first one postulate is all matter is made up of very tiny particles called atom. Matter, all matter, matter, what is matter? Anything which will occupy space and will have the mass will be called as matter. So all matter is made up of very very small particles which will be called as atom. And it was the first postulate of Dalton's atomic theory. So if we are considering any matter, so this matter will be made up of very very small individual particle, better to say individual very tiny particles which will be called as atom only. So atom will combine together to form matter. Means all matter is made up of atoms only, which is the smallest individual particle, according to the first postulate of Dalton's atomic theory. So this figure is of atom only. Now we'll move to the second postulate of Dalton's atomic theory, which is atoms are individual particles. Second one postulate, atoms are individual particles which cannot be created nor be destroyed in a chemical reaction. Means matter which is made up of very tiny particles which will be called as atom will be indivisible. Means you cannot divide this individual particle which is atom. You cannot divide this atom according to Dalton's atomic theory. However, in the chapter 4 you will look that atoms can further be divided into electrons, protons and neutrons. So we will talk about that, but according to Dalton's atomic theory, the second postulate will say to you that atoms are individual particles which cannot be created and cannot be destroyed in a chemical reaction. Meaning is that if we are considering this, this reaction in which the hydrogen is combining with chlorine to give hydrochloric acid. So in this reaction you will look, this is the reactant side and this one is the product side. So left hand side is the reactant side and the right hand side is the product side. So on the reactant side, if you carefully look, that there are two hydrogen atom and two chlorine atom. But on the right hand side, there is only one hydrogen and one chlorine. So you will balance it. Here is two hydrogen, two chlorine. That's why we will write twice of HCl. So the second postulate tells to us that a chemical reaction must be balanced. So you will remember a chemical reaction must be balanced because atom can neither be created nor be destroyed in a chemical reaction. So if you cannot create and cannot destroy the atom, so atom on the left hand side must be equal to the atom on the right hand side in a chemical reaction. And when the atom on the left hand side will be equal to the atoms on the right hand side, so your reaction will be balanced and a chemical reaction will be always balanced. So you'll remember that a chemical reaction must be balanced because atom can neither be created nor be destroyed. Now we'll come to the third postulate of Dalton atomic theory, which is atoms of given element are identical in mass and chemical properties. Elements, where are the elements present? Elements are present in the periodic table. So elements also, everything in this universe is the manifestation of atom only. So elements also will be made up of atoms. And if you are considering any particular element, so atoms of given element are identical in mass and chemical properties. It is the third postulate of Dalton atomic theory. And the fourth one postulate will tell to you that atoms of different element have different masses and chemical properties. Means third one postulate, in a particular element atoms will be identical in mass and chemical properties, but when are you considering two different elements? So elements will be made up of atom only. So atoms of two different element will have different mass and different chemical properties, and atoms of same element will have identical same mass and same chemical properties. And it is the third one and the fourth one postulate of Dalton atomic theory. Now we'll come to the fifth one postulate of Dalton's atomic theory, which is atoms combine in small whole number ratio to form compounds. Atoms combine in small whole number ratio to form compound. So the fifth one postulate, atom combine in a small whole number ratio to form compound, is looking something known to us. If you will recall the law of constant proportion, which was elements combine to form compound in a fixed proportion by mass. And the fifth one postulate, atom combine in a small whole number ratio to form compound, is looking something similar to the law of constant proportion. So this fifth one postulate of Dalton's atomic theory is the explanation of law of constant proportion. And the last one postulate of Dalton's atomic theory was the relative number and the kind of atoms. The relative number and the kinds of atom are constant in a given compound. The relative number and the kinds of atom are constant in a given compound. Meaning is that if we are considering water compound, so in water the number and the kinds of atoms will be same, no matter from which place we are considering it. So relative number and the kinds of atom are constant in a given compound. Means water compound elements are hydrogen and oxygen. So there will be 2 hydrogen, 1 oxygen. The relative number and the kinds of atom, means hydrogen and oxygen, will be always same. And it is the sixth postulate of Dalton's atomic theory. Now we will talk about the drawbacks of Dalton's atomic theory from the next video. Thank you all.